Okay, so hello everyone, good morning. My name is Lucas, I'm from Brazil, and today I'm going to talk to you a bit about metaprogramming in JavaScript and show you how we can solve problems in a creative way and show you some techniques we can use for that when it comes to metaprogramming. So here are my social networks in case you want to follow me or get in touch, send any doubts, whatever you want. I'm there, so let's get started. Well, what is metaprogramming? Metaprogramming is a programming technique in which programs can treat other programs as input. So this right here is metaprogramming. We have a JavaScript code manipulating Java code. And this is metaprogramming. But it's not exactly what we're going to be talking about. Because here we've got two languages. We've got JavaScript in the meta level and Java in the base level, which is the language being manipulated. So what we're really going to be talking about is reflexive metaprogramming. And reflexive metaprogramming is when both the base level and the meta level languages are the same. And it's based mainly around three things. Introspection, when a language can read and interpret itself, when it can be aware of its own structure. We've got self-modification, when a language can change itself, maybe even when in runtime. And we got intercession, which is when we can intercept operations and maybe even change their behavior. So we can't really talk about metaprogramming without talking about the meta-object protocol. So what is the meta-object protocol? The meta-object protocol basically defines how objects behave and how we can communicate with them. So it's not really important to read everything that's written here. You just got to notice that there are a few steps even when you're just accessing a property. So this is what happens whenever you try to retrieve the value of a property. We've got three steps here. First, we got to check if what we're going to retrieve the property from is really an object. Then we got to check if the property key we pass to it is really a valid property key. And then we'll call the get operation. As you can see here, it's inside double brackets. So what happens is that get is an internal method. It's implemented by our JavaScript environment. So this is the internal get method. And as you can see, again, it's not really important to read everything that's written here. You just got to notice that there are a bunch of steps even when you're just trying to retrieve the value of a property. So keep in mind that whenever you do operations on objects, the meta-object protocol defines how they behave. And there are a bunch of other methods here which define how objects behave in some other situations. So if you want to read the full list and know how it works, you can go to this link and read the spec. Well, I highly recommend you to do so because sometimes when you face errors and you don't know why they happen, you may want to read this and know what's happening behind the scenes when you're just doing simple things. And we also got to talk about the objects methods, the global objects methods, because we're going to use a few of them in this talk. So let me introduce you some useful ones. First, we've got object.keys, which retrieves the name of every property an object has, every enumerable property. Then we also have object.assign, which copies properties from an object to another. We've got object.hasOnProperty, which checks if an object has a certain non-inherited property. And we also have object.getAPrototypeOf, which retrieves the prototype of an object. And we're going to use a few of these later, so keep them in mind. And let's get to the most meaty subject of this talk. First, I got to talk about property descriptors. And property descriptors are objects that describe properties characteristics. They're kind of like meta properties. So if before you were seeing objects like this, now I want you to start seeing it like this, because every property has an object inside it that defines how it behaves. And this right here is a property descriptor. So I'll go through each one of these keys and tell you what they're all about. So first, we have value. And value indicates the real property's values. This is usually what we get when we retrieve a property's value or the value that changes when we assign to it. Then we have enumerable, which indicates if this property shows up when we're enumerating properties. So do you remember object.keys? Well, A property will only show up there in the result of that function when it's enumerable, otherwise it won't. Then we have writable, which indicates if a property can be assigned to using the assignment operator, and configurable, which defines if a property descriptor can be changed or not. And it's important to notice that these two are very different. So what configurable does is it does not allow you to change a property descriptor at all, but you may change its value if you use the assignment operator. So if you have a property that is not writable, but it's configurable, you can change its property descriptor, and you can pass a value here, so its value will change. So if you don't want your value to be changed in any way, it's better for you to set writable and configurable to false. So these two are very different. And here's where the real magic happens, because with get, we can trigger functions, we can invoke them when we access properties. So this function will run whenever we try to retrieve the value of a property. And set does the same thing when we set a value. So when we set a value for this property, the set function will run and will be passed the value we're trying to assign to this variable. And here's where the magic happens, as I said. I'll show you some cool things you can do with these two as soon as I talk about how to set property descriptors for properties. And for that, we got to use object.defineProperty, which defines a property in an object, obviously. And it takes three parameters. It takes the object we're going to define the property at, it takes a property name, and it takes a descriptor, which is the object I just showed you. So you don't need to necessarily pass all those properties. There are default values for some of them, for all of them actually. And you can just toggle the state of the ones you want to change. So if we want to retrieve a property descriptor, we got to use object.getOnProperty descriptor. So this takes only two arguments, object and a property name. It's also important to notice that this does not work for inherited properties. So if we want to retrieve a property descriptor for a property that's inherited, we need to use object.getPrototypeOf, which is the function I showed you before. So you can go up the prototype chain and then retrieve the property descriptor for the property one. So you can do this recursively until you get to object and then retrieve your property descriptor. So how many of you here have used Haskell before? Please raise your hands. OK, so as you might remember, Haskell has something called lazy properties, which are properties that are calculated only when needed. So we don't need to be setting properties before retrieving them. Let's say we have a basket object which has a few fruits in it, and it also has a weight property. So whenever we change the amount of fruits in our basket, we also got to change its weight property. So if we're doing too many assignments here, and we're not reading weight a lot, so we are wasting writes in this weight property. So if you want to keep weight always up to date without having to write to this variable every time you change the amount of fruits in your basket, you can just change it for a get function. And now if you have a getter function, when you try to retrieve the weight of this basket, the get function will be called, and it will calculate the weight only when you need it. So you don't need to be wasting writes to this property anymore, because now when the amount of fruit changes and you try to retrieve weight, it will be calculated again. So we don't need to worry about that. And also something cool you can do with it is fluid APIs. So this is an example taken from the Shy assertion library. How many of you have used Shy before? Please raise your hands. Well, as you can see here, these are just plain English, right? Phrases. So you, please, the ones that didn't raise your hands, would you like to try guessing what these statements do? Please raise your hands if you want to try to guess. Nobody wants to try guessing? OK, so I'll just tell you. Well, this one, you're just checking if word is a string, because you're expecting word to be a string. And the second one, you're just expecting this array to have a length of 3. You know, you can just read it, and you know what it does. So you don't need to read the docs to know what it does. And this is really important for us, because our main goal is to be understandable by everyone. And let me show you how we do this by using getters. So here, first, the expect function wraps a value into an assertion object. So word goes into this object. And now these two words here, they're not just retrieving a property's value. They're actually triggering a getter function. So whenever we use access the to property, for example, we're getting the assertion object back. So we can keep passing it forward and calling other methods in it. Sometimes you can even trigger assertions itself just when accessing properties. So what these two do is they just keep passing forward the assertion object, and now this thing right here is a function which does the actual comparison. So basically you pass the assertion until here, and when it gets here, you return the value inside the assertion object and you do your verifications. So also these two, they may not only return the assertion itself, they may also set flags we can use later for other assertions. For example, if you had like a deep flag here, and then you use a equal assertion here, what the deep property access does is it sets a flag on the assertion by triggering a function, a getter function, and then when it comes to the equals assertion, it uses that flag to determine its behavior. And that's pretty much how shy works. So now let's talk a bit about setters. So as I said, setters are triggered when you try to assign values to properties. And here, let's say we've got a person object and we have three properties in it: first name, last name, and full name. And what we want to do is we want to set first name and last name whenever we assign to full name. So here, we're going to assign a name to full name, and what will happen is the set function will be called and will be passed John Doe. So we can split this string and then assign the values to the right places, as you can see here. It's also important to notice that we need to be careful not to set full name again inside our setter. So if we do this, we end up having infinite recursion, because the setter will be calling itself whenever it assigns to itself. And in order to solve this, we can also use getters, because then we won't need to assign to full name anymore. We can just use a getter to concatenate those two values, and so we can get full name without even assigning to it inside our setter. But before we get to proxies, I'll do some live coding and show you how property descriptors really work. So I'll just create a file here, just split my screen. Okay, so I'll run node mode. So whenever I save this file, it will run. Okay, this file exists. Yeah, it does. So let's say can everybody read it? Okay, so let's have a basket object here, which has a few fruits in it. So let's say we have bananas, we have a few oranges in it, and we also have strawberries. So now we create a function that logs the contents of this basket, which we use later. So it takes a basket, and what it does is, let me just use const. So we use object.keys, which returns an array with all the keys in our basket. So it gets all the keys in basket and joins them using a comma. And now we just console log this basket has, and we log the contents of this basket. So this is really simple, but this is not all I'll show you. I'll log contents. I missed an S. Okay, so now we know that this basket has bananas, oranges, and strawberries. However, if we have like a weight property here, which is like 100, and we don't want it to show up when we enumerate properties for this, right? Because this is not a content of our basket. It's just a property of it. So we need to use object.define property. And this is how you define property descriptors. So we can just define a property descriptor for our basket. And the third argument, as you will see, is a property descriptor. So we'll say this is not enumerable. And now it won't show up anymore because object.keys won't retrieve it, and it's not here anymore, as you can see. So also, as I've warned you about writable properties, I'll just try to change the value of weight. So I'll show what happens in this situation. Well, so I'll set basket.weight here, and it will be now like 200. So if we try to set this value right now, it will work. But however, if we turn writable to false, nothing will happen because we can't assign to it using the equals operator anymore. But we can still use object.define property to change its value because we can pass a value inside our property descriptor, as you may remember. So if we change its value like this, it will change. So now, as you can see, even though we have a non-writable property, we can still change its value. So if you don't want this to be possible, you just gotta set configurable to false, and now we'll have an error telling us that we can change this value, we can redefine it because it's not configurable anymore. And well, now in order to demonstrate how getters work, I'll do a Fluent API here. So I'll just create a person which will do the actions we want to do with our basket. And what we want to do is we want to be able to write person.getBasket and add 10 bananas. So this is pretty much how Shy works, and I'll implement the exact same way we do there. Of course, we have some more checks to make it work on all the browsers and everything, but this is basically how it works. So first, I'll implement get to show you what it does. So what we want to do here is we want to use object.define property to define a getter for that. So we'll define a get property in our person, and we will pass a property descriptor here. You use a getter function, and as you can see, what we're doing here is we're invoking a function. So this getter must return a function in order for us to be able to call it. So we will just return a function. I'll use an arrow function here, so this is the same here and outside here. And what we want to do is we want to set this dot hands to the item that gets passed when we call this function. So this hands now will have item, and we will also return this, so we can keep chaining stuff. And this is pretty much what Shy does. It does its things, it sets its flags, and then it returns this assertion, so we can keep chaining stuff. And now, if we do this, you'll see that person will have a basket in its hands. So I'll put this here and here, and I also gotta remove this so we won't see. Okay, so person had nothing, now it has a basket in its hands. So let me continue implementing the other things here. Well, and is just a simple chaining word. So what we want to do with it is we want to return this so we can keep chaining stuff, as the to and be properties do on Shy, as I told you. So now I want to implement and, right? And here we got to get a function which just returns this so we can keep chaining stuff. Then we must define add, and add must set a flag in our person object so that we can know the amount of bananas we want to add later. So this getter function here must also return a function, because again we're calling a function here. So we will return a arrow function which takes an amount, and now we will flag this amount into the person object. So this dot amount equals amount, and we must also return this again here. So if we keep returning this, we can keep accessing properties and triggering behavior on property access. So now we just gotta implement bananas. which is the most fun thing ever to implement. So right here, as you can see, we're not invoking any functions. So bananas must trigger a behavior only on property access. We may not need to call it if we want to trigger its behavior. So this .hands.bananas will now be equal to the amount we flagged. Oh, not equal. Let's add. And let's return this, because we may need to change things again. So hopefully it will work. Oh, I made a typo here. And another typo. Add and. Oh, yeah. Thank you. So this might do it. So I'll log person before and after we do that. And now we have 20 bananas. Before we had 10. So what we're doing here is basically when we type person.getBasket, it adds the basket to the person's hands. And when we just access the end property, it returns this, so you can keep chaining stuff. And add just flags the amount of fruits we want to add and returns this. And finally, bananas we run on the same object we had in the beginning, and we add to the amount of bananas we have. Also, if we want to have the same thing for, let's say, oranges, we can just do this, and we can have an oranges property, which adds to the amount of oranges. And now we can type and add 5 oranges. So again, it's just plain English. As you can see, we had 2 oranges, now we have 7. So this allows you to do pretty cool things when you're using property descriptors. And you also need to notice that this is something that many IDEs will complain about, because they will say that here you're not using this for anything, because, well, you're just accessing a property. And your IDE will tell you that this is not useful. But actually, in JavaScript, it is, because we can trigger a function when accessing a property, which can have side effects. So in this case, you might want to ignore your IDE's warning. And that's something you got to be careful about, because many people, when they use Shy, they end up getting errors telling them that they're not doing anything on property access. But yeah, they actually are. So let's get back here and talk about proxies. So proxies are just object wrappers, and they can have traps defined so we can intercept operations. Well, if you remember that get operation I've showed you from the meta object protocol, well, we can intercept that and the other ones too by using proxies. So this is what a proxy looks like. It has a target object, which is the real object we're wrapping into our proxy, and it also has a handler. So this handler right here defines some traps that will be triggered when some specific operations from the meta object protocol happen. So here, for example, this trap will be triggered when we access a property. So this is what happens when you create a proxy and when you assign it to a property, to a variable. Actually, this is a value. I'm using Costa. So here we have our proxy wrapper, and it wraps target, which is the real object we're wrapping into our proxy, and it also has a handler. So handler defines operations to happen when certain events happen. So if we don't want to trigger the original get behavior when we retrieve a property, we might want to have a trap for get, and then it will be triggered. So this whole proxy wrapper gets assigned to P. And now when we try to retrieve a property from P, our proxy will detect that, and the get trap will be called. So it will be passed the target itself and the property name we are trying to access. Now the value returned by this function will be what you get back when you retrieve this property. So you can do this for many things. You can also do this for set, for when getting prototype of something. There are lots of traps you can use. You can see all of them on MDN. They got great material about it. So this also allows you to do cool things like infinite arrays, which in Haskell are called list comprehensions. So we can have an array that can give us back numbers for every index possible. Here in this example, we have an infinite array with all the even numbers in the universe until number explodes. So what we get back when we access the 0 index in this is the get trap runs because we're just accessing a property which is called 0. Then our proxy wrapper will check if it exists in the underlying array, and if it does, we can get this value back and give it to our users. But let's say we want to try to access something that has not been calculated yet. So we want to get what's in the index tree, and as you can see here, it's undefined. So when we do that, our get trap will be called, and it will check if a value exists here. If it doesn't, we can calculate the value that should have been there, and we can return it. So our users will get back values for every possible index in this array. This also has been implemented. It's on GitHub if you want to check it out. I've used plenty of metaprogramming techniques there. I've used generator functions, used the symbols, and if you want to take a look at it, it's a pretty good resource to learn how to do this kind of thing. You can also use this to give property suggestions back to your users so they can figure out how to use your API properly. Well, for example, if you have a person object and someone tries to access a property that does not exist, you can always check if it really exists on your target object, which has been wrapped inside your proxy. And if it does not exist, you can just return, oh, perhaps you mean first name, because this is the correct property name we have. And this is actually a problem we also had in Chai, because if you remember, well, we're just invoking things on property access on the assertion object. So if anybody did something like this, they would just get back undefined and no assertion would run. Because, well, this right here just returns undefined. It does not trigger the getter it was meant to trigger for this assertion. So people were getting their tests to pass without having assertions to run. And this was really bad because, well, we're doing tests. We want things to be checked. That's the whole purpose of this thing. So what we did was we wrapped our assertion object into a proxy. And now, whenever you access a property that does, for example, sets a flag or does an assertion, we check if this property exists in the assertion object. So if it does not exist, we list all the properties we have, and we run an algorithm called the Levenstein algorithm, which calculates the distance between two strings by seeing how many deletions and additions we need in order for one to reach the other. So we give back our users the name that looks like what they need. So here, they made a typo, and now we're suggesting them to use the string assertion instead of the st or ng assertion. And well, this was great because now our users would know that their tests weren't running fine instead of them just passing without running anything. And well, these are just some ways you can use metaprogramming to solve your problems. And also, it's useful to talk about reflect when we talk about proxies. Because, well, reflect was introduced in ECMAScript 6, and it allows us to call those internal operations like get, set, and this kind of stuff in a functional way. So we have, for example, reflect.get, which just triggers the default behavior for retrieving a property. We have reflect.set, which triggers the default behavior for setting a property. And we have reflect methods for every trap we have in the proxy object. So if inside your proxy function you want to call the original behavior for that operation you're intercepting, you just got to use reflect dot your trap's name. And now you can pass to reflect the same exact arguments your function receives in its trap. So for example, here we're tracing property access, which is something you can also do with proxies. We're logging property access to the console, and then we are retrieving its real value by using reflect.get and passing it the exact same arguments we have here. As you can see, both names are equal, and they also have the same parameters. They take the same arguments. Before we get to symbols, well, I'll just show you how to define a proxy in our basket object. So let's have an intelligent basket. So this intelligent basket is just a proxy which wraps our basket, and here goes every trap we want to have. So we can have like get traps, sweat traps, well, any trap we want. I'll just use a get trap here. So this trap takes a target object, which is the object we wrapped inside your proxy, and it takes a property name. So now, if this property name exists on target, we can just call reflect.get, passing the exact same arguments to it, and we can return this. So we can return this and give back the real value of this property. Otherwise, we might just do console log and tell our users, hey, this does not exist. And we can tell him to try one of these. And we can give him back object.keys for target and join them with a comma. So we also return new. Well, just show you what happens. So now, if we try to access something that exists in our basket, let's say bananas, we will get back its real value. Right? So we have 10 bananas. However, if we access something that does not exist, such as bandanas, now we have some property suggestions here telling us that what we tried to access does not exist, and now we can try one of those. We could use also the Levenstein distance algorithm or anything you want to have better suggestions for users. And it's also important to notice that the intelligent basket object is different from the basket object. Because, well, as you can see here, it's different because the basket object is actually inside a proxy. It's not the proxy itself. And proxies are also transparent. You can never know if something is a proxy or not just by doing checks at the object itself. So this means that you never know if you're triggering traps or not when you're accessing object unless you have it stored somewhere else. And also the other methods of the basket are intact. So we can set to bananas without triggering anything, because here we're not triggering the get trap. So you can let's set this to 8. Oh, I shouldn't have erased that. And now it just works. So you won't trigger any other traps if you want to define only a single one. And finally, we'll get to symbols. And symbols are a new primitive type also introduced in ECMAScript 6. So I think the best way to define how symbols can be used in metaprogramming is this one. Because, well, symbols are all about reflection within implementation. This is something a friend of mine from London has written in his blog, and I think it's the best way to describe how we can use symbols to guide and drive native operations. So before we talk about that, we need to distinguish symbol with lowercase s from symbol with uppercase s, because this one right here is a primitive type, while the other one is an object wrapper. So this is a global function, and that one is the primitive type. When we create symbols, we don't use the new keyword, because it denotes creation of a new object, and this is not what we're doing here, because what we want is a primitive object. So the new keyword denotes the creation of a new object, and that's not what we want. To create a symbol, we must call the global symbol function and pass a description to it. So this returns a new primitive symbol. And well, primitive symbols are awesome because they are unique. So a symbol will never be equal to another symbol, even though they have the same description. This, for example, will return true because, well, a symbol with a description ID will not be equal to another symbol, even if they have the same description. However, we got to be careful with the global registry, because we have a global registry of symbols which stores symbols globally, obviously. And, well, if we use the for method, what it does is it tries to find a symbol with this description in the global registry. If it can't find one, it will create a new symbol with the description and return it. If it already exists, it will just return the existing symbol. And this is why these two will be considered equal, because they're not different symbols. They're the exact same symbol, because this was retrieved from the global registry, and it returned the same symbol because we have the same description. So these two are the exact same primitive. Be careful with that. And now in the real world, you can use symbols in order to prevent any properties from being reset unintentionally. As you may remember, we use the amount of fruits we are going to add to our basket, in our example, to the person object. And well, if someone used the same property name to store the amount, well, then we would lose important metadata we would need later. So if we want to mark a timestamp on a third-party object, for example, if we have a library that marks timestamps on objects, well, then we would create a property called timestamp and assign a value to it. So this could be easily overridden by a mistake, because someone might want to have a timestamp property in their objects, and they might not know what we're doing. So this could end up erasing important metadata for us. So if we want to prevent that from happening, we can just use a symbol to index this property. And now, if anyone wants to assign to this property, they'll need to have a symbol for that, which is unique, by the way. However, here, it's not impossible to assign to this property. It's just impossible to assign unintentionally, because someone can still get all the symbols in an object and then use it to reassign to this property. So this just avoids unintentional assignments. And well, well-known symbols is what we were talking about when I said about driving native operations. So in a meta-object protocol, some steps of algorithms use functions implemented in objects indexed by symbols in order to drive their implementation. For example, if we have an instance of operator here, what is really happening behind the scenes is JavaScript is calling the function stored in symbol.hasInstance in our awesomePlace constructor. So it's invoking the function stored there with the instance we're passing it. So this right here allows you to guide the behavior of instance of. It will not just run, it will run your function. And this is how you drive native implementation. So here we're redefining symbol.hasInstance and assigning a function to it. So it will run whenever we use the instance of operator. So we have many, many symbols which allow you to do lots of things, such as symbol.toPrimitive, which allows you to define what will happen when you try to coerce your object into a string or into a number. We have symbol.toStringTag, which allows you to change the tag when you call toString on an object. We have symbol iterator, which defines iterative behavior, and many others. You can play with regex, and you can even play with the with keyword, which is something many people don't know about, exists in JavaScript. And it allows you to do crazy things with scope. It allows you to change the scope inside its block. But, well, it's not recommended to use, but you can play with that if you want. And, well, that's it. Before I get to the end of this talk, I'll just implement a simple symbol here. So whenever you're implementing symbols, it's important to see if they're writable or not, because it might not be possible for us to do something like this. Let me just write some boilerplate code here. So has Banksy graffitis, because anywhere that has Banksy graffitis is an awesome place. And we also have awesomePlace constructor here. So when you're defining symbols, as I said, it's important to see if they're writable. So if you try this, Bristol symbol.hasInstance, if, oh, I made a typo here, it might not work because symbol.hasInstance may not be writable. And in order to work around that, we got to use object.defineProperty because it's configurable. So you can change its value by defining a new property descriptor. So let's define a property in our awesomePlace constructor, which is indexed by symbol.hasInstance. and we'll change its value by passing a new function to the property descriptor. Well, it takes an instance, and it returns instance dot has Banksy graffiti. So now, whenever we use the instance of operator, so oops, awesome place. So now this will be true. Let me just comment this. So I'll show you it was false before. So as you can see, it's false because Bristol didn't came from this constructor. So if we define this symbol, now this function will be called when you use the instance of operator, and therefore it will return true because Bristol has Banksy graffitis. Whoops. Typo? Oh yeah, there's a typo here. Forgot an N. So as you can see, this was a function that ran when you use the instance of operator. So it does not run the exact same behavior anymore, because we told the internal implementation that it might want to use our own function implemented for this symbol. And well, I think that's all. I hope I've showed you some more creative ways to solve your problems and showed you how you can interact with how JavaScript works. So if you want to know more about this, you can go to my blog. I have 4 blog posts about it with every symbol, how you can use them, how you can work with inheritance and everything in JavaScript. So you might want to take a look at it. And if you want to send me tweets with any doubts or follow me on GitHub and get in touch through there, if you want to get involved with open source, I'm always eager to help. And this is all for today. Thank you for being here. It was awesome. That's it. So do you have time for questions?
I think I haven't got a watch on me. I think we do, because no one's radioing me. So if anyone does have any questions.
So if you have any questions, please raise your hands. I'll be happy to answer you.
Does ES6
No, can you just wait for the microphone so we can have it recorded? Thank you.
does ES6 classes use some of the methods that you defined earlier in your talk? So like has defined property, is that how it understood how it gets
Well, actually, the new class syntax is just a syntax sugar for creating prototypes. So you can just use object properties, and you can set it just like you would in a normal object.
So it will hook. So like if you wanted to do a static method in a class, it would hook into like say it's not writable and stuff like that.
Well, then if you want to do that, you gotta use the constructor, because well, the class will be the constructor, and this prototype will be used by its son object. So if you want to define a method for the prototype, for the constructor function, you might define it in your prototype. Do you get what I mean?
Yeah, I think so, yeah.
Okay.
Anyone else have any questions? Thank you. Is that everyone? Okay. That's it.
Okay, that's it? Okay, thank you.